Hello, this is Eric Nersessian. I'm presenting research on the Pre-College Computer Science Initiative for Augmented and Virtual Reality Development. Other authors on this paper are Adam Straczynski, Tracy Espiritu, and Dr. Michael Lee. We are all from the New Jersey Institute of Technology and the Passaic County Technical Institute in New Jersey. So, new curricula initiatives are necessary to meet near future industrial demand of computer science graduates, in this case, the emerging technologies of augmented and virtual reality development. So, universities are often at the forefront in these curricula developments as they prepare their students for industry jobs. And high schools that want to offer college aligned CS courses, it's very easy for them to come and approach their local universities to adopt these courses for their student needs as opposed to them developing the curriculum themselves. So this paper presents an effort along these lines and results from our student surveys in our university class, along with our training workshop of the high school teachers. The curricula is available for public use at artandcoding.com and may be adopted as needed by educational programs to meet the emerging employment needs of further students in the AR/VR fields. So these emerging technology fields are becoming major job markets for future computer science graduates. And AR/VR can be very appealing for graduating high school and college students due to its visual and immersive natures. Multiple reporting agencies have written reports about the large growth expected in the augmented and virtual reality fields. Some reports are that Business Wire shows that AR is expected to be worth $60 billion by 2020. Extended Reality reports that a $209 billion market size for AR/VR by 2022, and Consultancy UK predicts that the market for AR/VR will grow to $178 billion by 2022. So all of these reports show that these new CS skills will become very vital in the growth of our nation and global economy. So to address these emerging industries, our university, the New Jersey Institute of Technology, or NJIT, has been developing curricula for undergraduate AR/VR software engineering for several years. This was a natural extension from our pre-existing game development program, which shares a large overlap of skills and knowledge. High schools and colleges can take advantage of these university efforts by adopting the curriculum and the instructor resources that have already been established by a lot of universities for game development to help foster this new AR/VR growth. So here in New Jersey, the Elizabeth School District learned about this growing CS trend of AR/VR development while working with researchers at the New Jersey Institute of Technology. And to take advantage of our existing program, the Elizabeth School District decided to enhance their own CS program by incorporating our college-level AR/VR development courses as electives in one of their technology high schools, the John E. Dwyer Technology Academy. So the goal was to boost student participation in computer science and to increase the number of students graduating with both college-level and industry credentials. So there's been a lot of research into how these new AR/VR development courses are being taught in computer science and showing that the existing teaching methods are feasible and ready to be used in these new emerging technologies. So some researchers found that the traditional teaching methods are predominantly used in AR/VR education, and that developing a course focused on building creativity in a team setting with designers and developers has allowed the instructors to use the virtual reality platform to integrate graphics development and design in a consistent and fun educational manner for both the engineering and design students. So these instructors have observed that students are paying more attention to interaction design when developing these virtual reality applications. And as well as these students are investing a more significant, larger amount of time in their projects due to its visual nature and the student's passion with that. Other papers have examined the usefulness of augmented reality in teaching science topics like biology by comparing teaching materials based on 2D graphics and then to 3D graphics and objects using these AR/VR technologies. The student interviews indicate the interest and satisfaction with using augmented reality, and the researchers conclude that these new AR/VR tools are very valuable for educators for hands-on learning. So, high school computer science teachers face a variety of challenges in their teaching field. Some researchers conducted a larger study that covered these challenges, resulting in revealing that there's inadequate preparation and training for these teachers. They found that a lot of the teachers have to learn a lot of this technical content on their own, even if they had little or no prior experience, which makes it much harder to learn. They found that professional development workshops are successful in exposing teachers to technology and resources available in computer science education. And some programs, such as Exploring Computer Science, combines content knowledge with instructional techniques in a workshop-like environment to make a strong case for empowering teachers to introduce these active learning in their settings, where traditional curricula has proven inadequate. So at the university level, we have a class called Information Design Techniques. It's an overview of interaction design tools, techniques, and principles focused for 3D development using Unity. We find that it's a fun, engaging way to use 3D graphics to teach programming and the interactive design needed for software engineering. So this course teaches 3D project structure as the students create and customize a 3D painting tool using feature-driven development. The curriculum covers project management, sprint-based development, C# scripting, 3D computer graphics, interaction design, user flow diagramming, animation, rendering, physics, and user input. Long list of everything needed for 3D development leading into AR and VR development. So the course is split into 4 sections. Each section has 4 weeks, and each week has 3 hours of class and 3 hours of project time. So each section starts with, it's sprint-based, where the students have to deliver a project at the end of each sprint. Each sprint has a focus that builds up the sophistication of the piece of software that they're building. Sprint 1 is focused on user input, 2 on 3D graphics, 3 on animation, and 4 on refactoring, or cleaning up their code. Understanding that they hit all these major milestones with their coding, now they need to step back and clean it up because software engineering is a team-based principle. In addition to that, it's very common with software engineers when they come back, they'll forget a lot of their code, so they need to be very legible. So the instruction of all these weeks is also accompanied with practical exercises to learn by doing, and then at the end they must demonstrate their skills with a project and a final exam at the end. So this curriculum was modified for the high school based on their needs. So their core motivation was that they were getting CS enrollment dropouts after the first and second year in high school. The administration wanted more opportunities for the students to apply their programming skills in trending or fun, engaging computer science areas. After polling the students, they found that the students felt that computer science was not interesting, and this was resulting in low engagement and low enrollment in their advanced courses. The students communicated that they had a strong interest in gaming and multimedia, and this is why they selected computer science. So based on this, the administration thought that these new emerging and visual technologies of AR/VR would be a great area to add to their catalog to enhance students' interests and their career opportunities. And they decided to base their curriculum on NJIT's undergraduate class. And as you can see in this graphic, we have our 4 sprints at the top dealing with the undergraduate class that got broken out into marking periods. So basically, one semester undergraduate course turned into a 2 semester or a 1 year high school class. So as this curriculum was converted or extended out into 1 year, it was a joint effort with the college faculty, the career and technical advisors, supervisors, and the high school computer science teachers. The teachers were trained on the curriculum with a training workshop the summer before the first year. This was released at the high school level. And the teachers were to determine that the complexity of the curriculum and how to pace it appropriately for the high school students. So we had weekly meetings between the college faculty and the high school teachers to adjust the curriculum accordingly. At the end, the 13 weeks of the college curriculum was doubled out, was slowed down, so it became like 26 weeks. It was 1 week of a lecture or instruction, followed by a week specifically on project-based learning to make sure that the students understood what was taught to them. So we formed an advisory board, and we built a pre-college agreement between the university and the school system. The advisory board consisted of the supervisor from Elizabeth, 2 faculty members from NJIT, and we had representatives from the educational branches at Unity Technologies and Facebook. The collaboration with NJIT and the industry partners helped ensure alignment with NJIT's curriculum and provided students the opportunity to earn college credits along with industry credentials such as the Unity Certified Developer certification. NJIT has a Center for Pre-College Programs that partners with public schools across the state, and we signed an agreement through this organization that if the Elizabeth school system follows the curriculum that was set forth, that high school students who graduate and choose to come to NJIT can get credit for this undergraduate class in their collegiate enrollment. So once the curriculum was developed and ironed out over the weekly meetings, we held a workshop to train the high school CS teachers in Unity to build these 3D and VR programs. The meetings between the college faculty and the high school curriculum writers were successful in acclimating the curriculum. And the workshop was run for 4 days. The first 3 days were full 8-hour training in Unity, C# programming, 3D graphics, user interfaces, and animation workflows. The training went through the college level curriculum in a condensed, quick format, but we touched all the bases to ensure that the teachers could then follow along with the whole suite of training videos, the lectures that were recorded, so that they could prepare independently for their coming academic year. The last day was completely about equipment, training, and handling, so using these virtual reality headsets and a lot of issues that arise when you're going to use them in the classroom with students and how to deal with those issues. So we took 2 semesters worth of surveys to students in the undergraduate class. The surveys were designed as a questionnaire with 8 questions, each ranked on a 5-point Likert type scale from what is your knowledge level on, and we insert the topic there. So question 1 to question 8 on the right-hand side. What is your knowledge level on Unity, C# programming, interaction design, 3D development, animation, user interfaces, and Visual Studio? Now, these are all actually fall under 2 categories. These are 4 questions on programming and 4 questions on interaction design. So we polled them at the beginning of the semester and then at the end to see what the changes on their scores are. 1 meaning I know a little bit, 5 meaning I know a lot. Each semester had 4 courses or close to 100 students polled for a total of close to 200 students. As you can see, the beginning of the first semester, beginning of the second semester, were relatively low, about 1.5, or if you look at the first semester, their average was 1.76 at the bottom. The second semester was 1.89. So they were close and low. And if you look on the second part of the graph on the right-hand side, we have the first semester, end of semester, and second semester, end of semester. And they're all relatively higher. So 3.5, 3.82 and 3.692. So they're both very similar at the start of the semester and at the end, and you see a large difference. In addition to these quantitative questions, we did ask open-ended questions to get further qualitative feedback. So it might be easier to digest this survey data in a graph format. So on the left-hand side here, you see the same 8 questions. What is your knowledge level on A, B, and C on these different programming and design topics? And at the bottom, just the average of all 8 questions. Now the graph is reporting the 8 questions along the horizontal and the strength of the average score on the vertical. And in blue, we have the start of the first semester, and in orange, the start of the second semester. And across the questions, you can see they're relatively low compared to the end of semester for the first semester in gray, and end of the semester, the second semester in yellow. So based on these surveys, here are the aggregates of the 4 programming questions and the 4 design questions. You can see that the deltas, the average difference between the beginning of the semester and the end of the semester, in the programming questions, we have about 1.62, 1.68, so the 2 semesters about even, and the design questions raised 2 points, or 2.02 and 1.91. So these are mostly technical students, programming students, so this is the first class where they would have been exposed to more of a design side. So you can see that they have a half a point or 0.4 on average higher raise in their feelings of their knowledge at the end of the class. But in either case, I think we can call this a successful class in their learning objectives at the undergraduate level if we've had 200 students reporting these average increases in their scores. So some of the qualitative feedback, we had some positive feedback. They had to deal with the appreciation of the curriculum ideas, completing the project deliverable successfully, and feeling emotionally fulfilled with the class. They said that the flow was logical, it felt correct, and that the training videos and giving the project source code was very useful. There was also negative feedback. We had some misalignment of the curriculum, some technical issues using Unity that we had to deal with in extra lab time. They felt that the survey, the broad style of the class, was a bit too much when you had to jump into the silos of like animation and graphics and scripting. It was a lot to take in. It is a broad survey course. So they did some of the technical issues with like different versions. Unity will come out with like multiple versions throughout the year, and so during the semester, some students will upgrade when they weren't supposed to, and some of the projects will break. And you should really stick to that version of Unity when the semester starts and stick with it for the year. So in conclusion, we developed this curricula initiative to meet industrial demand for this growing field of augmented and virtual reality for up-and-coming CS graduates at the undergraduate level. Universities are often at the forefront of developing these curricula initiatives to prepare students for these industry jobs. And so that high schools that wish to have these college-level courses should work with their local universities and adopt the curriculum. Student surveys from our university classes for 2 semesters worth have showed successful implementation of this augmented, the beginnings of this augmented virtual reality development. The further classes, this was really like intro just to 3D, base foundation, which leads our students at the university level at the junior and senior year into the more advanced augmented and virtual reality classes. But this shows that they have their foundations correct before they go into those more advanced classes. So this curricula from the study is available for public use at artandcoding.com, and it may be adapted as needed for educational programs to meet the emerging employment needs for their students in the augmented and virtual reality fields. Thank you.